Hello everyone, welcome to this problem, lexicographical numbers. So basically in this problem we receive as input n and we are supposed to return all of the value sort in lexicographic order. What does that mean? That means in the lexicographic order sorting, 10 will be considered smaller than 2. 11 will be considered smaller than 2. So we are kind of comparing them as if they were string. So for us to solve this, I'm going to share with you two approaches. The first one is actually the one that is not aligned with the requirement, because we want you to have something in big of n and the space of big of 1. But the first approach we are going to use is going to use like natural sort, and we are going to see how it performs. And after that, we are going to implement something big of n. The idea of the first one is just like to show you how to have a custom comparison function, and it's interesting to know that because it can help you during an interview. So let's start with the first one. So with the first one, we are going to go with like the result, which is going to be a vector of int. We are going to call it result, and it is the guy we are going to return here. And here what we are going to do is that we are just going to loop less or equal to n e plus plus. So from this we have all our elements. So while looping, what we need to do is just to append the element like this. After this, you have all your elements be stored in like integer sort normally. So now you need to apply like just a custom sort here. We are starting from result.begin till result.end, and we want to have a custom function. We have to have a custom function left and right, where we are going to return to string of left is actually smaller than to string of right. So basically this is the first idea. So you have all your elements that you are placing normally, and then after that you are sorting them based on the string value, because you know that the string value comparison is going to sort them into lexicographic order. Let us run and see first. Oh no, error. What is happening? Internet. Okay, so it is working. You have everything is green. Let us submit. Okay, despite not meeting all the condition, it was able to go through, so it's working. Now let us try to implement something that will help us to have big of one time. So the idea of big of one time will be as follow. So what I will do is that I will loop from element from 1 till 9, because I have 9 here also, and for each of the element I'm going to recursively loop from 0 to 9 and display the element until I'm not able to add more element. I will not be able to add more element if the element is actually greater than the target. So let me give you an example. We are going to loop from 1 to 9, and for each of the element you are going to have a recursion function that is going to call, actually is going to insert the element first if it's possible, and after the insertion of the element is going to call a loop which is moving from 0 to 9, and for each of the element is inserting the element and recall the helper function. So what will it look like in code? So in code we are not going to need this anymore, because it's actually the previous logic, and we want to keep track of our result inside out of here, because we are going to manipulate it both in our helper function and in the lexical order function. So here you return the result that you are creating here, and then you are going to have a void helper that is going to take two number in parameter. We are going to have the number where we are, and then we are going to have the limit. That means it's where we are going to stop, right? And for this, what we need to do is that we first need to check whenever we want to deal with recursion, we need to know the breaking condition. So if the number is actually greater than the limit, then we return. So there's nothing to do. Otherwise, what we are going to do, we are going to add the number, and after adding the number, we are going to loop the 9, and for each of the elements, what will happen here is that you're just going to create a new number and call it into and recall the helper. So you can do it even in one sentence, that you're going to say helper of numbers times 10 plus 1, and the limit is not changing. So what does this mean? When I'm saying helper times 10.1, that means when I'm here, what I'm going to call, when I'll be at 0, I will call 1 times 10, which is 10 plus 0. After, when I'll be here, I will call 1 times 10, which is 100 plus 0, which is this one. And then if I cannot go 4 character or 4 digit, after this I will call 10 times 10 plus 1, which is 101. So after this will be 101 if I cannot go down here. So that is the logic. Let us run. Oh, I have a problem. So I'm not calling my helper function here. So I should call my helper function here. Helper function of 1 under n. Okay, so we have 1 1 1 1 1, which is not good. I'm not incrementing it up properly, so it's not plus 1, it's plus I. Yeah, plus I, like I was saying, yeah, plus I, because after year you are you are adding this time 10 plus 0, this time 10 plus 1, so you are adding plus I while moving. So I'm still missing. Why? Because I'm just ending here. So I need to also add for the others, and for that is actually simple. So I'm gonna look for int moving from 1 less than or equal to 9 e plus plus. So this is all what I need to do, and here I need to do I. It's not this, because I know that the first integer will only move from 1 till 9. Wow. From 1 till 9, that means 1 2 3 4 until 9. So now we have everything going. Let us submit. Oh, I have a wrong answer somewhere. What is happening? From 1 till 9, I'm having this from 1 till 9 also. This is from 0 or from 1 till 9. Yeah, this is what should happen. I don't know why I just missed this, because I'm moving from no from 0 to 9. Sorry, from 0 to 9. Yeah, performing a little bit better. So I was just missing indexes here. You're moving from 0 to 9 as has been set here. This one is moving from 1 to 9, but the other one down here I'm moving from 0 to 9, because those are all the possible digits. Yeah, so that was the thing I was missing here. But overall, this was my approaches of solving this. I hope you did enjoy it. Feel free to give me any input. I'll be really happy to interact with you regarding this. See you tomorrow for a new challenge. Ciao.